this lesson, we're going to use transformation rules in order to transform various functions. So last time we talked about the different types of transformations, which are translations, reflections, and dilations, and we looked at how the graph moves from the parent function based off of different transformations. But now we're going to look to see how the equation of the function can tell us how the graph is moving. So the first transformation we're going to look at is a translation, and that occurs when a constant is added or subtracted to the parent function. So there's two types of translations. We have a vertical translation and a horizontal translation. So vertical translation, that's going to be exactly what you think happens. So if you have a function and you have something added to the outside of the function, that's going to move it up that amount. If we have something that's subtracted from the function, it's going to move down that amount. So plus is going up, minus is going down. So in this example here, we can see that the parent function is x squared, and then we're adding 3 to the outside, which means that this is really going to move up 3. In this function, our parent function is the square root of x, and we are subtracting 5 from that, so that means that it's going to move down 5. With the horizontal translations, that means that the addition or subtraction is inside the parentheses or attached to the x. So if we look at example 1, that is a cubic is the parent function, so x cubed. Notice that the minus 8 is attached to the x. It's inside this parentheses. So that means that it's going to be moving, in this case, to the right 8. So if it's a minus inside, it's going to move to the right. If it's a plus, it's going to move to the left. So horizontal transformations are kind of like opposites. It's like opposite world, and it's very strange because it's exactly the opposite of what you think would happen. So when we think about things that might move to the right, we think positive is to the right and negative is to the left. So the horizontal translations will be the reverse of what you think. So a minus we think really goes left, but it goes right. So this would be right 8. And then here we can see that the parent function is the absolute value. And now we have plus 1 inside the function with the x. So since we're adding 1, that means that we're going to go to the left 1. Okay, so this is really just about memorizing how these translations are moving and then being able to explain it from the equation. Okay, next we're going to look at reflections. These occur when negative 1 is multiplied to the parent function. So we have two options here. There can be a reflection across the x-axis or a reflection across the y-axis. If there's a reflection across the x-axis, the negative will be in front of the function. If it's a reflection over the y-axis, the negative will be attached to the x inside the function. So here we have a negative on the outside, so that's going to be across the x-axis. So I'm just going to put x-axis. And same thing here, x-axis, because the negative is in front of the function. Now in these two examples, the negative is attached to the x. So when it's attached to the x inside the function, this is going to be a reflection over the y-axis. So both of these are examples of reflections over the y-axis. And our last type of transformation is a dilation. And again, there's two types. There's vertical and there's horizontal. And again, these can be a little bit confusing. Dilations occur when a number other than 1 is multiplied to the parent function. So first we're going to focus on vertical dilations. So if we have a value that's multiplied in front of the function, that means that we're going to have a vertical dilation. If that value is greater than 1, it is a stretch. And if it's between 0 and 1, it is a shrink, or it's also called a compression. So I'll just write that here. Okay, so when we look at this example, we can see that there's a 2 in front. So that means that this is going to be, it's in front, so it's vertical. And it's a stretch because 2 is greater than 1. And we're going to say it's a stretch by 2. So 2 is the factor at which it's being stretched by. So this is a vertical stretch by 2. In the second example, there's a 3/4 that's in front, Again, it's in front of the function, so again, this will be a vertical dilation. And in particular, because 3/4 is a number between 0 and 1, this is going to be a vertical shrink or compression. And it's a vertical shrink by 3/4. So when you're looking at vertical dilations, it's going to be by the number that we actually see here, so by 2 and by 3/4. Now, horizontal dilations are, again, bizarro world. So everything that you think you know, it's the opposite, which is kind of confusing. So if we're looking at horizontal, that means that the number being multiplied is attached to the x inside the function. And it's the opposite of vertical. So if you see the number that's being attached to the x, if it's between 0 and 1, that is a stretch. And if it's greater than 1, it's a shrink. And what's important to note here is that the factor that we're using here, so in this case, this was stretched by a factor of 2, this was shrunk by a factor of 3/4. The factor that we use here will be the reciprocal, meaning that we're just going to flip the numerator and denominator. And we'll explain what when we actually look at this example. So here we have 1/4 x, and then the whole thing is being squared. So the 1/4 is being multiplied to the x inside the function. So since we see this inside, we know that this is going to be horizontal. And because 1/4 is between 0 and 1, it is going to be a stretch. And instead of being a stretch by 1/4, the reciprocal of 1/4 would be 4. So it's a horizontal stretch by 4. Now you can remember the horizontal rules here. What I like to do is just remember one of these two because they're kind of confusing. If you know one of them, the horizontal will be the opposite. So I tend to remember the vertical, and then I just think it's the opposite. So for instance, if I see 1/4, in vertical, that would be a shrink. So in horizontal, it's the opposite. So it's going to be a stretch. And literally every time that you're writing the word stretch, whether it's vertical or horizontal, the factor that follows it has to be a number greater than 1. And every time we write the word shrink, the factor that follows that has to be a fraction between 0 and 1. So that can kind of help you out as well. So if you knew this was a horizontal stretch, but you put 1/4, 1/4 is not greater than 1, so that couldn't be the number we put after the word stretch. Okay, if we look at this example here, we have the square root of 9x. So again, notice the 9 is attached to the x inside the function. So that means it's going to be horizontal. Okay, because it's 9, it's greater than 1. In this case, it's going to be a shrink. And if you're thinking about it in terms of vertical, normally it would be a stretch, so horizontal is the opposite, so it's a shrink. And it's going to be by the reciprocal, so by 1/9. Okay, it just takes a little bit of getting used to, but those are our 3 rules. So once we know the 3 rules, we can combine them and have multiple transformations within one function. So we'll look at examples of that. So identify any and all transformations that occur in the functions below. So let's think about the parent functions. So for this parent function, I'm just going to write the parent up here. The parent function is going to be x squared. Okay, we see that 2 as the exponent, so that's our quadratic. And we just want to see from left to right, how is this transforming? So I don't have anything in front of the x. The first thing I have is this +2. The +2 is attached to the x on the inside. So that's going to be a horizontal translation, and that means it's going to go right or left. So since we have a plus here, we know that this is going to move to the left 2. And then we have this -1 on the outside. And since we have a number being subtracted on the outside of the function, we know that that's a vertical translation, and this will be going down 1. So this is translated left 2 and translated down 1. Okay, if we look at the next example, the parent function is going to be the absolute value of x. So we're just kind of comparing these two. Again, start with the farthest left. So the first thing I see is this negative. Now be careful here. Negative and then the 1/2, they're two different transformations. We have a negative and we have a 1/2. So this is very similar to saying -1 times 1/2 times x. So there's the -1 and then there's the 1/2. They're two different things. And then x is just like the parent part that we started with. So the 1/2 is being multiplied to the x. So that's going to be some type of dilation. The -1 is going to be some type of reflection. Okay, so they're not the same thing. So the negative in front, because it's inside the absolute value bars, it's part of the function, it's with the x, so this will be a reflection across the y-axis. So we can say reflection over y-axis. Then we have this 1/2, and again that 1/2 is inside with the x, so when that's inside we know that's going to be horizontal, and it's a 1/2 inside, so that's going to be a stretch, and it's a horizontal stretch by the reciprocal because it's horizontal, so by 2. And then the last thing we have is this +5, and that's outside of the function, so that's going to be a vertical translation, and because it's plus, we know it's going to go up 5. So we're able to notice how the function is moving based off of these transformation rules. Okay, and then the last one we'll look at here, we'll say that the parent function, just so we have it written down, is the square root of x. Right, that's the parent function, and then again, starting from left to right, we want to see what's happening. So we have a negative, and again, the negative and the 4 are two different transformations. We have a negative, and then we have a 4. So the negative, it's outside of the function, right? It's not underneath the square root, it's not attached to the x. So this means it's going to be a reflection over the x-axis. And then we have this 4. That 4 is on the outside of the function and it's being multiplied to it. So this is going to be a dilation. In this case, because it's outside, it's vertical. And it's greater than 1, so it's going to be a stretch. And it's a stretch by 4. And then the last thing we have is this +3 on the inside. And the +3 is attached to the x, it's underneath the radical, so that means that it's going to be a horizontal translation, and in this case that means it's going to be going to the left 3. Okay, and then just to kind of look at it from the other perspective, if I had the words, so let's say I want it to be reflected, let's start with g of x equals absolute value of x, let's just say. And if I want it to be reflected over the x-axis, and I want it to be horizontal stretch by 2, and I want it to go left 5 and up 7. Okay, I'm just making this up. So if we're starting with the parent function, I'm going to make a new function here, f of x. So the parent function is the absolute value of x. So I'm just going to literally I'm going to write it crazy like this. So we have the absolute value of x. That's our parent function. And now we're going to take that function and we're going to do these things to it. So we're going to reflect it over the x-axis. So reflecting over the x-axis means that we're going to have a negative in the front of our function. So we're going to put a negative here. Horizontal stretch by 2. So since it's horizontal, we know it's going to be inside attached to the x. And if it's a stretch by 2, that means that it's really the reciprocal that we're going to write here. So this is going to be 1/2. If it's moving to the left 5, that's going to be inside with the x. And if it's left, we're going to use a plus sign. So this will be +5. And then it's going to move up 7. So outside of our function, we're going to have +7. So this would be the function that we're using given the parent function and given the description of the transformations, what the new function would look like.